Hi there and welcome. My name is Rebecca Weaver and I'm going to be solving a system by elimination today. Our first example is one we've seen before. We're going to find the solution to this system by elimination, but first remember we've already done this with graphing and we've done it with substitution. Our two equations are y equals 3x plus 4 and 2x plus y equals negative 6. When we solved this equation by graphing, we found that the solution was x equals negative 2, y equals negative 2. You'll notice we graphed them. We found where those two lines crossed. When we used substitution, we found exactly the same answer. Now, when we go to solve using elimination, we should expect that we get exactly the same answer with this too. So step number one, we're going to write the equations with the variables all on one side. Now we're going to use our intuition to choose a variable to eliminate. Now it doesn't matter which one, it's just that sometimes one is easier than another. So we'll use our intuition to go, "Ooh, which one should I eliminate?" Once you get it set up so that you can just add them and eliminate a variable, you do that. You'll then simplify it and solve it for that unknown variable. Next, you'll do what we've been doing before, which is substitute your answer into one of the equations and solve for the other remaining unknown. So let's look at our equations. First up, y equals 3x plus 4. Notice step one says get all the x's and y's on one side. So what you're going to want to do is you're just going to want to rewrite this equation. We don't need to bother with the second one because he's already got both the x's and y's on one side. So what I'm going to do is subtract 3x from both sides. When I do that, I'll get negative 3x plus y equals 4 for the first equation, and I get the same thing for the second one. Now I'm going to look at these two equations, and I notice there's a y in both of them. So if I just multiplied both sides by a negative 1, I'll get a minus y for that bottom equation, and if I added them, the y variable would disappear. So let's watch me do that. I've distributed that negative 1 and got negative 2x minus y equals 6 for that second equation. Then I'm going to add. So here we go. I get negative 5x equals 10. I'll divide both sides by negative 2, and I'll get that x equals negative 2. Hey, that's what I got the other two methods that we used. Perfect. That's what you should get. And there are other methods. This is a very important skill and you'll be doing it quite a bit. So there are other methods in addition to these three that we are looking at today or in this unit of work. And then we just do what we did before. We take one of the equations. I chose this one, plop in that negative 2, compute my answer, and I get y equals negative 2, which is what I got before. And you can also write this as the point negative 2, 2. All right, let's look at another system. We've seen this system before as well. Y equals 2x minus 2 and y equals negative 5x plus 5. So we already know what the answer is. The answer is x equals 1, y equals 0. We're going to solve this using elimination, and then we should get those exact same answers. It shouldn't matter which method you use. It's just sometimes you can only use elimination, and in other times you can only use substitution, so you've got to know them all. So here's our two equations. I'm going to need to rewrite both of these equations, moving the x's over to the left-hand side is what I'm going to do. So for the top equation, I'll subtract 2x from both sides. And I get negative 2x plus y equals minus 2. In the bottom equation, I'm going to add 5x to both sides. And I'll get 5x plus y equals 5. Staring at this one again, I have that same scenario that I had before. I have the y's. So if I pull that same trick, multiply everything through by a negative 1, then I will get same top equation, the bottom equation. That distributive 1 makes it look like negative 5x minus y equals negative 5. I'll then add those two equations, giving me negative 7x equals negative 7. Dividing both sides by negative 7, I get x equal 1, which is what I already knew. Do what I did before, take an equation, plop in that 1, compute my answer. I get y equals 0, which was what I got before. I can write it as point form where x is 1, y is 0. All right, so let's look at another system that we've looked at before. We already know that for y equals 3 and 2y minus 3x equals negative 6, the solution to the system is 4, 3, and that can be written as x equals 4, y equals 3. Now to solve using elimination, we are going to, oh wait a minute, I already know what one variable is. I can jump on down to number 5, substitute my answer, and solve. And there I go. X equals 4, y equals 3. I already knew what that was, or I can write the point 4, 3. All right, let's look at another example. This is a set of equations we haven't seen before. We have 12x minus 3y equals 6, and we had negative 12x plus 3y equals 6. So I guess step number 1 is done because the variables are all on one side. Perfect. Let's see. We're going to choose a variable to eliminate. We'll just choose the x. Look how if I add 12x and negative 12x, that'll be a 0. Let me do that. So I'm just going to add them. Oh, wait a minute. I get 0 x's, 0 y's, and 6 and 6 are 12. 0 equals 12? That's not true. So let's see what's going on. Let's look at what this set of equations looks like on a graph. So here's this equation. I want to graph it. I like for it to read y equals so that I can read off my slope and my y-intercept. So what I do is move my 12x over by subtracting 12x from both sides. I'm going to divide everything through by a negative 3. So this equation is y equals 4x minus 2. Okay. So that's what that equals. The y-intercept is negative 2, the slope is 4. I'm going to draw that in just a second. Let's look at the other equation, the bottom equation. Negative 12x plus 3y equals 6. I'm going to add 12x to both sides, and I'll have 3y equals 12x plus 6. I'll divide everything through by a 3, and I'll have y equals 4x plus 2. So let's graph this. Let's graph that y equals 4x minus 2. So first up, my y-intercept, negative 2. I'm going to go up 4, run 1, draw my line. There's my blue line. Let's draw the red line. Y-intercept, 2. Slope, 4. Up 4, run 1, draw a line. Oh my. These are parallel lines, and they will never cross. They will never have the same solution. This is a case of no solution. So if you end up with something crazy like 0 equals 12, which is not true, you know that there's no solution because they're probably parallel lines. You don't have to graph them, but it sure does help to see why they will never have the same answer. All right, let's look at another one where I've changed a sign a little bit. So 12x minus 3y equals 6, and negative 12x plus 3y equals negative 6. So here's our elimination instructions. I already have number 1 done, so I'm just going to write those two equations down, add them up. In this one, when I add, because 12x minus 12x is 0, negative 3y plus 3y is 0, I get 0 equals 0. Hey, well that's true. I don't know what it means, but at least it's true. So let's rewrite these equations so that we can graph them and see what's going on, because I don't really know what this is. So I'm going to take this equation, I'm going to subtract 12x from both sides. I'm going to divide everything through by a negative 3. And I get for this one, y equals 4x minus 2. For my bottom equation, I have negative 12x plus 3y equals negative 6. I'm going to add 12x to both sides, and then I'll divide everything through by a 3. And I get y equals 4x minus 2. Wait a minute. These two equations simplify to exactly the same thing. They're the exact same line. The solutions that work for one work for the other because they're exactly the same line. No reason to graph this same line on top of itself. I already know This is the case of infinitely many solutions. All right, and that's all we have for finding solutions to systems using elimination. If you have more questions, be sure and email me, rweaver10 at alaska.edu. Have a wonderful day.